Good day, ladies and gentlemen. So we are still busy with equations and we're solving equations with fractions in this lesson. So I'm going to just go straight away to examples and we'll go through the rules as we go along. If I look at an example, the instruction is you have to solve for x. So then you must know that you're going to get an equation. So my equation that is given is I have a fraction with 3 as a denominator and a fraction with 2 as a denominator equal to 1 on the right hand side. So the first thing I need you to do always is to remember that the numerator forms a single term, and so that you don't make mistakes with signs or when you multiply with the LCD. The first thing you always do when we solve equations with fractions, put the numerator in a bracket, because that's one number and this numerator is another number. So that's thirds and that's halves. So once you have done that, let's see. It's fractions. I need equivalent fractions to do calculations, which means that you need to find the LCD. So if I look at 3 and 2 and 1, because that one I don't write, the LCD will be 6. Right, there's two ways that we can do this. The quick way is you can straight away multiply with the LCD, because then that way you will get rid of the fraction. I'll show you now what I mean. So if I multiply right through, so it means every term must be multiplied with the lowest common denominator. I'm going to say it's 6 times, and my fraction is x plus 2 over 3. Plus, and then I multiply the second term with the LCD, which is 6 times, x minus 1 over 2, and that must be equal to, and I do the same with the 1 on the right hand side. I say 6 times the 1. So what happens now? The 3 will go into the 6 twice, so I will have 2 there. The 2 will go into the 6 3 times, so I will have 3 there. And 6 times 1 will be 6. So let's rewrite that. See what we have. We have 2 times x plus 2, and it's over 1, so I'm not going to write that, plus 3 times x minus 1 over 1, which I don't write, must be equal to 6. No more fraction. I'm sure you are relieved about that. So now it's the same as a linear equation. I simplify the expression on the left-hand side by distributing the 2 into the brackets so that I can get rid of the brackets. So that's what I'm going to do now. And I'm going to get 2x plus 4 plus 3x minus 3 is equal to 6. So now let's simplify this further. I add like terms. There's x's and there's numbers. So I can add 2x to 3x. That will give me 5x. And I can add 4 to negative 3, which will give me just 1. And all of that must be equal to 6. So with all equations, my mission is to get the term with the variable on its own on the left-hand side. So I don't want this plus 1 here. So I'm going to use inverse operations, which means I'm going to subtract 1. And what I do on the left-hand side, I must do on the right-hand side. So I'm going to subtract 1 on both sides to keep it balanced. So on this side, I'm going to get 5x. 1 minus 1 is 0. And on that side, I'm going to get 6 minus 1, which is 5. So now I have 5 times x is 5. I don't want 5 times x, so I use inverse operations and I divide with 5 on both sides. So this 5 will go into that 5 once, this 5 will go into that 5 once, and I will get x equal to 1. So the root or the solution of my equation is x must be equal to 1. So that is the one way you can do it. The second way you can do it, and this is a bit longer, but I think some of you are more familiar with that, is I changed the fractions so that they are equivalent fractions. So once again, I'm going to have, so just look at this, I'm going to have x plus 2 in brackets because it's my numerator over 3 plus x minus 1 over 2, and I'm going to say it's equal to 1. So the LCD is still 6. And now I'm going to change the denominator so that they are the same. So what must I do with 3? I must times it with 2. And what I do under the line, I must do above the line. So I must multiply with 2 there. What must I do with 3 to get 6? I must times with 3. What I do under the line, I must do above the line. So I must times with 3 there. 1 is 1 over 1, so I must multiply with 6 under the line. And what I do under the line, I do above the line. What does that give me now? I can write this as one fraction because, just do this, because I all have the same denominator now. So I can say, and above the line, I now have 2 times x plus 2 plus 3 times x minus 1 equal to 6 over 6. So I have the same denominator on both sides. So now it's very easy. It's one term on the one side, one term on the other side. It's very easy to get rid of it. I just use inverse operations. I times with 6 on both sides. Denominators will cancel out now. And my fraction is gone. And I'll get exactly the same as what I got there. So from there on, I do it exactly the same way that I did with that one. Does that make sense to you? Right. So let me just clear the board and then we'll do a second example. So for the second example, I now have an equation. I'm still solving for x. And there I have a fraction. And once again, the first thing I do, I put my numerator in brackets because they form one single number. And that numerator in brackets. So get that out of the way. Then I look and I see I've got 3x, 24 and 4x as an denominator. So I need the lowest common denominator of 3x, 24 and 4x. You should know that 3 can go into 24 8 times and 4 can go into 24 6 times. So that means that my LCD here, let's write it on this side now, my LCD will be 24x. Okay, right. So now I'm going to follow the first, we're going to multiply all the terms in the equation with the lowest common denominator, which is 24x. So I'm going to say 24x times the first term, which is x minus 2 over 3x minus 24x times 1 over 24 must be equal to 24x times my fraction on the right hand side, which is x minus 1 over 4x. So let's simplify all the fractions. So 3x will go into 24x 8 times. And 24 will go into 24x x times. And 4x will go into 24x 6 times. So what is left now? My fractions, my denominators are going to be gone, and my fractions are gone. So I just have 8 times x minus 2 minus x times 1, and that must be equal to, on that side, I have 6 times x minus 1. Now once again, guys, distributive property, I want to get rid of all the brackets so that I can put my variables together and my constants together. So I distribute into the brackets, and I'm going to get 8 times x is 8x, 8 times minus 2 is minus 16, minus x times 1, which is minus x, equal to, on that side, I'm going to get 6 times x, which is 6x, and 6 times negative 1, which is minus 6. So now, let's get everything to, let's simplify this side first. I have 8x minus x, so here I have 7x, and I have minus 16, and on that side, I have 6x minus 6. So now I have a problem because I have x's or variables on both sides. So I'm going to take, because I've got less variables on this side than on that side, so I'm going to subtract use inverse operations and subtract 6x on this side so that it falls away on this side, it makes 0. And when I do it on this side, I must do it on that side as well. So what I'm going to do now is I'm going to say 6x minus 6x. And what I do on the one side, I'm going to subtract it on that side. So let's write this out nicely. So here I'm going to get 7x minus 6x, which I got from that side, minus 16 equal to, and then I'm going to have 6x minus 6x, which is just going to become 0. And 0 minus 6 is minus 6. So 7x minus 6x is x. Minus 16 equal to negative 6. So I don't want negative 16 here. I want x on its own. So once again, I use inverse operations. To get rid of negative 16, I'm going to add 16. And what I do on the left-hand side, I do on the right-hand side. And I'm left with, on this side, I'm going to have x. Minus 16 plus 16 will give me 0. Is now equal to negative 6 plus 16, which is just going to be 10. And that is solved. The root for this equation is x is 10. And finished and closed.